Our universe is a vast and complex system, both magnificent and chaotic. Yet the infinite dance of the stars follows a set of laws and rules that cannot be broken. Humankind has yet to scratch the surface and see for itself the true beauty and order of the universe.
In the same year as the death of Galileo, Isaac Newton was born in the hamlet of Woolsthorpe, England, 1642. He was the only son of a local yeoman. He was a weak baby and was not expected to live through the night of his birth, but miraculously he survived. Newton attended Cambridge in 1661. At this time in history, the scientific revolution had already begun. Galileo had proposed the principles of inertia, and many other scientific leaders began to formulate a new conception of nature as an intricate, impersonal, and inert machine. Like most of the scholars during this time, Newton studied Aristotle. In 1664, he wrote Questiones quadam philosophicae. Under the title of the notes, he wrote, Amicus Plato, Amicus Aristoteles, Magis Amica Veritas. Meaning, Plato is my friend, Aristotle is my friend, but my best friend is the truth.
Newton's scientific journey began after the completion of this notebook. He again started with Descartes, from whose law geometry he branched out into the other literature of modern analysis with its application of algebraic techniques to problems of geometry. He then reached back for the support of classical geometry. Within a little more than a year, he had mastered the literature, and pursuing his own line of analysis, he began to move into new territory. He discovered the binomial theorem, and he developed the calculus, a more powerful form of analysis that employs infinite considerations in finding the slopes of curves and areas under curves.
Although Newton studied many different subjects, he mastered literature, language, and mathematics before diving into science. In the 1790s, Newton's name was everywhere. He was established because of his theory of gravity, which he wrote in the Principia. The Principia lists answers to many questions. It contains Newton's laws of motion, classical mechanics, as well as his law of universal gravitation, and a derivation of Kepler's laws for the motion of the planets. Newton rewrote the majority of his mathematical arguments in the Principia. In formulating his physical theories, Newton developed and worked on calculus. This advanced mathematical genre helps in the study of science, economics, and engineering.
It is in a supplement to the Principia entitled General Scholium that Newton expressed his famous quote, Hypothesis non fingo, which means I make no guesses. The significance that Newton brought to the Enlightenment period of the 18th century is through his work on the Principia. He made science perfect and included order, defining what is nature and what is not. Newton wrote like John Dryden, Alexander Pope, and Jonathan Swift. They all wrote in the organized fashion. Newton wrote the formula in which words and uses of science had to be written. The heroic couplets are examples of perfect order and rhythm. John Dryden uses heroic couplets in Macflecknoe. Alexander Pope's essay on criticism uses nature and Homer to describe the perfect way to write and yet not to copy classical works. To copy would be impossible. Pope mentions nature as a parallel to writing. Jonathan Swift's A Description of a City Shower mentions lightning and thunder as a way to parallel the city's power and also to parallel its faults. Newton's nature was on the real outdoors and the nature in the sky and mountains, but similarities between nature and writing poetry are almost the same during the 18th century. Nature was perfect, and therefore writing had to be perfect.
Isaac Newton's ideas influenced John Thomas because John Thomas is a simpleton who is a subcontractor who works with numbers. Newton discovered a new and easier way to calculate numbers. He uses the formulas of mathematics to calculate items needed for the East India Company. The aspect of the semiosphere during the Enlightenment is that Newton used symbols to figure out new and better calculations that would benefit the 18th century world. He discovered many ways to help people figure out sciences and the natural forms of life in the 18th century. Newton discovered different aspects of science and math that helped move the 18th century progress forward, which therefore helped simpletons like John Thomas.
The culture of the Enlightenment was based on order and beauty. Through words and ideas, Isaac Newton formulated the theories of nature and beauty and concluded that nature does not change. Newton's ideologies inspired what is known as deism, which is the theology that God is observable only in physical laws of the universe. The creator was merely a clock matter that arranged the universe, set it into motion, and then left. Newton's observations went in opposition to the Catholic Church's teaching and biblical understandings. Newton's culture, through his books, taught many people about the world and what it is made of. His theories helped simpletons to realize that one person can grow and expand in the knowledge. Newton gave power to the knowledge to know about the world around them and to change it in any way that they wanted. They should work with nature and harness what is possible. This knowledge became known as the cosmopolitan selfhood, or realization of a distinct autonomous self. This was the power of the people in the 18th century. They were looking at themselves in a new order that was beautiful.
Newton's three laws of motion are perhaps the most well-known of his works, and cite the following. The first law, or the law of inertia, states that an object at rest will remain at rest, and an object in motion will remain in motion, unless acted upon by an unbalanced force. The second law states that acceleration is produced when an external force acts on a mass. Newton's third law of motion states that for every action there is an equal and opposite reaction. Newton invented the first reflecting telescope and devised a theory of colour. The theory was based on the observation that a prism breaks down white light into many visible colours. Newton is attributed with the development of differential and integral calculus, as well as the generalised binomial theorem. He also developed a method for approximating the roots of a mathematical function. A highly religious man, much of Newton's writings consist of biblical and occult studies. Sir Isaac Newton is considered by many to have one of the greatest scientific minds in our history, and he is buried in Westminster Abbey.
Isaac Newton, I mean, you read his writings. Hair stands up on, I don't have hair there, but if I did, it would stand up on the back of my neck. You read his writings, the man was connected to the universe in ways that I've never seen another human being connected. It's kind of spooky, actually. He discovers the laws of optics, figures out that white light is composed of colors. That's kind of freaky right there. If you take your colors of the rainbow, put them back together, you get white light again. That freaked out the artists of the day. How does that work? Red, orange, yellow, green, blue, violet gives you white. The laws of optics, he discovers the laws of motion and the universal law of gravitation. Then a friend of his says, well, why do these orbits of the planets, why are they in the shape of an ellipse, sort of flattened circle? Why aren't they some other shape? And he said, I don't know. I'll get back to you. So it goes home, comes back a couple months later. Here's why. They're actually conic sections of a cone that you cut. And they said, well, how did you find this out? How did you determine this? Well, I had to invent integral and differential calculus to determine this. Then he turned 26. We got people slogging through calculus in college just to learn what it is that Isaac Newton invented on a dare, practically. So that's my man.